Okay, in this video I will show you on how to do static analysis using Catia. Okay, first of all we need to import our image or our drawing. So in this case we want to do a static analysis of bracket. Okay, so first of all we need to apply material on these parts. Okay, you can select all and select apply material at the bottom of the interface. Okay, there is a lot of material here. We have fabric material, construction material, metal, others, paint. This is all the material. In this case maybe we can select, for example, steel as our main material. So now you will notice on your left side we already have the material in terms of steel. Okay, so we are in the part design. Okay, in order for us to do the simulation of finite element, we need to go into the interface of analysis simulation and generative structure analysis. Okay, then you have three types of analysis, which is static analysis, frequency analysis, and free frequency analysis. So we select a static analysis as our base analysis. So now we are in the interface of static analysis. Okay, then what we need to do next is conducting mesh. Okay, you can double click to the left side and double click the mesh. Okay, this is as a default of mesh. As we know, in conducting a simulation, the smaller the mesh, produce more accurate result. Okay, so in this case we just give a try a default mesh. Okay, then after that you can compare the result when you compare the result with the fine mesh. Okay, so we just okay here. So we are under meshing. Okay, once the mesh is done, what we need to do is we need to make a constraint. Okay, so try to find on your left side. Okay, you can take out all the main interface tools, then select here clamp. We call it as a boundary condition, which area that we want to fix. Okay, so in this case we want to fix at the bottom of the bracket. Select the face and select clamp. Okay, here we have a lot of type of clamp. So we have clamp here, we have surface slider, sliding pivot, ball joint, pivot. Okay, we also have user constraint. You can put your own constraint. So everything in under the constraint. Okay, then once we have done the meshing, next we have done the constraint, what we need to do, we need to put the boundary condition of load. Okay, in this case we want it, we can select here, there is a pressure here, distribution force, we have moment, we have bearing, load, we have other imported forces, then we also have acceleration, we have rotation, line force density, okay, volume force density, and the rest. But in this case we want to use distribution force. Okay, then we are in the distribution force, so we need to select which area, which support that we want to apply force. So in this case I want it to apply at this surface, select this surface, then okay, you will notice there is a force vector here. As a default, it will be everything in 0 force. Okay, so in this case we want the force acting at the y-axis. This is your y-axis. Y-axis pushing, giving a load at the face. Okay, so if we take it y-axis, for example, you make it 1000 Newton. Okay, you will notice here when 1000 Newton, the arrow is towards the right, means it is a pulling force. But in our case, we wanted a compression force, so we just need to put negative here. Then you will notice the arrow is giving a compression force towards this surface. Then once you have done, you just select OK. So now our boundary condition of fix or claim is already here. Our force is already here. Okay, once this is done, next we can compute the simulation, and just select compute, select all. Okay, you can go mesh only analysis case, but normally we will select all, so it will run directly all the simulation. Okay, okay, yes, click yes. Okay, now your simulation is done. Now the next is post-processing. Okay, for the post-processing, you can select here is there is a deformation to see the deformation effects. Okay, this is your deformation effects. Okay, then if you want to animate, you can select animate here. You can see how this deformation happened with the force acting. So you can play with the step. This is the more faster, so this one can become your animation. Okay, then we have the most important thing, we have von Mises stress. Okay, we can select von Mises stress here. So this is the value of von Mises stress. The red color means higher stress, and the blue color means the lower stress. Okay, we can change this one to be shading. Okay, so here you will notice the high stress happen at this area. Okay, so this is the most critical point area for the stress analysis. Okay. If you want to edit the legend, you can double click here. You can select how many colors for the legend. For example, we want it to be 15. Here also you can change the style. For example, we want it to be scientific with 3 decimal point. So you will notice there will be 3.67 exponent 7. Or for example, we want it to be decimal point, so it becomes something like this. In this case, we want it to be scientific in 3 decimal point. Then you will notice this is the result of von Mises stress. So means the highest happened at this area with 3.667 or 36 megapascal. Okay, then beside of von Mises stress, we have also displacement. Okay, this is the displacement. Okay, maximum happen at the top, which is 0.037 mm. You also have principal stress. Okay, and you also have precision. Okay, local area precision. Okay, so this is on how to do the simple structural analysis. Okay, we can also animate. You can see which area, the main focus area. Okay, you just need to select. For example, we want it to be a displacement. It should be under transition displacement. Select the animation. Okay. Besides that, you also can do a cutting plane. Okay. For example, this is your von Mises. You want to see what happened in the cutting plane. You just select cutting plane. Okay. Okay, this is your cutting plane. Maybe you can rotate it. Okay. For example, this cutting plane, you can move the plane, you can rotate the plane. Okay. For example, we want it to be something like this. So you just okay, close. You can see the effect of the plane. Okay, this one is view section only. So at this section, you can see the high stress happen here and low stress. Okay, this one, if you don't want it to be the cutting plane, okay, this one you can see which area. Okay. This one you can amplify the magnitude. Okay, for example, scale factor of 400 over. Okay, so you can change it, you can play around with these results to compare with different mesh or different material what is the best optimization results. Okay, thank you very much, hope you enjoyed.